Welcome to the Scaling Tech Podcast, where we help you manage your growing engineering team. Through expert interviews, we help you navigate the challenges of leading, hiring, growing, and nurturing your tech team to deliver the value your customers demand. Brought to you by agilityfeet.com, experts in staffing engineering teams in Latin America for clients globally.
So actually, you just doing your job, you can relate a lot. All you have to think about is that alternate perspective of like, okay, this system I'm working on and I've like written code for it. How would I try to take it offline? Like, how could I hold it ransom if I was like really mad at my employer one day? How would I, if I, got access to service A, but I really wanted access to like service C that had customer data, how would I get there? Like if I were just like a rogue developer, you're going to get really close to the attacker mindset that way. And that's what you want, because ultimately attackers have bosses and budgets. They think about ROI. They're going to take the easiest path they can to get to their goal. They're not going to do the crazy, like multiple 0 days chained together and, all of that stuff. So as long as you're thinking about kind of the obvious ways, like if you're a lazy developer, you would be able to like pivot in your own system and attack it. Probably you're going to eliminate a lot of the low-hanging fruit. And so that's something I'm hoping empowers a lot of engineering leaders is like, hey, maybe we can start just thinking about this as part of our like architecture and design thinking too.
Welcome to the Scaling Tech Podcast, the podcast for leaders of growing software engineering teams. I'm Aaron Syme here with my co-host, David Alfaro. David, what's the most secure software possible?
I would say that the software that it's built from a standpoint of security, which means that every action to build it is a security action. That will be my answer. Is that good?
That's good, but I had a lame joke in mind. I was just going to say the only secure software is the software you never deploy. It never goes into production. Then no one can attack it. It's my favorite kind. Exactly. Insert symbols.
Right.
But we all know that there really is no such thing as perfectly secure software. But that doesn't mean that we can just wait for bad actors to hack our software and then we should react to those attacks in the moment. We need a more proactive approach. And kind of what you were saying is really like that, right? Of thinking about security as you design and build the system. And that's what today's conversation with Kelly Shortridge is about. Today, we learned more about security chaos engineering and system resilience and how to build more resilient software. What did you find interesting about this conversation?
Kelly has a deep understanding of the world from a philosophical point of view. Kelly can translate that in an understandable way, easy to process and to put in action. So the book is fantastic. I really recommend buying that book. The most important, the highlight that I had during the episode is that what are the mechanisms to keep track of a very complex system, and how the fact of recognizing that it is a very complex and changing system is important to bear in mind always when you want to create a system that has reliance. So we discussed the reliance concept throughout the episode. So great episode, really great episode. I recommend it.
Excellent. Well, David, I'm slightly insulted that you said this conversation with Kelly is the most intellectual conversation you've had, because we've been having intellectual conversations for well over a decade, my friend. But it's okay. I understand. Yeah. This was a really good interview, a really good conversation. So let's get to our interview with Kelly Shortridge. Kelly Shortridge is a senior principal at Fastly and lead author of Security Chaos Engineering, Sustaining Resilience in Software and Systems from O'Reilly Media. Shortridge is best known for their work on resilience in complex systems, the application of behavioral economics to cybersecurity, and bringing security out of the dark ages. Shortridge is a frequent keynote speaker, advisor, and author, and has been a successful enterprise product leader, entrepreneur with an exit to Crowdstrike, and investment banker. Welcome to the Scaling Tech Podcast, Kelly.
Thank you for having me. I'm super excited to be here. And with our competing neon signs, too.
That's right, exactly. For those of you watching the YouTube of this, Kelly and I do have competing signs. David's got some nice background lighting there.
He does.
He always has gone with a little more of the darker backlighting motif, and I try to go with a little multicolored. But you do need some neon lights in there, David. We're going to have to work on that.
I agree.
I will think about it. Advice taken. Yeah.
Feedback accepted. And maybe ignored. So, Kelly, let's talk about your book. And in your book, one of the things that you talk about is systems-oriented security. So I thought we could start with that, and maybe you can give us a definition of systems-oriented security and why the importance of working with security at the system level.
Sure. And I know your audience are not necessarily cybersecurity people, which is fantastic because I actually wrote the book with that audience in mind because I think cybersecurity has been really veiled in this sort of like mystical, arcane art vibe. It really isn't as difficult as the cybersecurity industry tries to pretend it is. So I'm hoping to demystify some things. So systems-oriented security, it's not actually that different than we think about things like software quality. I actually think security is a subset of software quality. And you can't have high quality software if only one component or even both components in a system, we pretend if there are only two components, are working. It's how they work together, right? That's really what powers an application or makes the whole system work. So when we talk about systems-oriented security, what we're talking about is making sure that all of the interactions between things are resulting in a system that's resilient to attack. Because you could have like a perfectly secure, like server, database, and it's the interaction between the two that can lead to like something going wrong, right? So it's very much encouraging people to not just think at the component level, but to think more about that systems level, which isn't intuitive for a lot of people, for human brains, especially the scale that we have today with a lot of our software systems is just enormously complex. It's difficult to mental model. So a lot of the book is trying to help any sort of leader or engineer kind of navigate how you build mental models of those systems, because ultimately when we think about security, again, it's how does the system respond to and adapt to any sort of failure, including things like attacks. It's not how the individual component does. It's like from a business perspective and a customer perspective, did the thing fall over or not? Like, was customer data compromised? Really, it doesn't matter whether things were secure or not on an individual level. It's about that whole system picture and behavior.
Yeah.
When I was looking at your book, I have a lot of comments about your book, but the first thing I noticed is when you introduce the concept of resilience. And while I was forming the concept in my head, it came to me as like that little thing that is on the fringe of the consciousness, like it's what is that? And I pay attention to that, and it was the concept of anti-fragility from Nassim Taleb.
Yep.
I think it's quite similar. I mean, anti-fragility, I have my notes here, is the idea that some systems can actually benefit from shocks and volatility. Now, when you are mentioning resilience in software and systems, you're referring to the ability to anticipate and respond to disruptions, learn from failure, and adapt to changing conditions. So, but I think that the innovation for me when I saw your book is the perspective of coming from this point, from resilience or anti-fragility. I mean, for me, it sounds a lot like anti-fragility, but resilience is it's I think gives a lot of emphasis to the system. I think to the nature of the system. Just wanted to make that comment. I think is that's for me is the innovation of the book. Everything that you say in the book comes from resilience, from that perspective. That's innovative.
Yeah, I like to think so. It's as you noted in my bio, I'm trying to drag cybersecurity out of the dark ages, which I think much of your audience likely agrees when they've had to interact with their security teams, it can feel very draconian, almost imperialistic with the thou shalt nots and imposing tools that the security team doesn't have to use, but you do. It can feel a little unfair. But from a resilience perspective, that's not what you can do anymore from a cybersecurity perspective. And even better, it means engineering teams are adopting more security responsibilities, not in a like now you get blamed way, but very much in a, if we need to be adaptive, that means we need to be solving a lot more of these security problems by design. That means we need to understand how to write software. It means we need to understand the systems we're supposed to protect. Guess what? Your cybersecurity team, most of the time, doesn't understand the system. You do, right? They don't know how to write software, but you do. So some of the book, especially towards the end, is very much a guide of like, hey, you want to start doing platform engineering, but for resilience, you absolutely can. So again, it's supposed to be empowering in a like, if the resilience is about the ability to, like you said, recover from gracefully and adapt to evolving conditions, recover from failure and adapt to evolving conditions, that's something you can do because failure can either be an attack. It could be some sort of, internet weather, as we call it at Fastly, or it can be some sort of performance related bug. Doesn't really matter the difference as long as you can make sure that your system is able to minimize impact and then you can change that system over time. So I'd like to think it's a very like nice and open philosophical underpinning in that way.
Now that you said the word philosophy, I want to tell you this. That book is special in something, and I don't remember seeing a book about engineering with that perspective. It's the most intellectual. Is the most intellectual book about engineering I've seen. Uh,
Oh, thank you.
and,
Oh, that's
and
such a nice compliment.
and the reason is this. It's because it basically talks about something that is called. I mean. Um, so you know what epistemology is?
Yes, of course.
Okay, I knew it.
I have a liberal arts background and I'm like a huge philosophy nerd, so go
That's
wild.
why. That's
Yeah.
why. That's why. I knew it. I knew it. I knew it. I knew it. Because clearly your book is coming from there. Clearly, it's about your book is about objectivity. It's there is a reality. The reality has a nature, metaphysics, and then there is the consciousness, which has a nature, and then there is the process how we understand reality by means of concept creation, and that is a process that has a specific nature. So your book understands and respects that through all the chapters, particularly when you talk in the chapter 2 about mental models, and
Yes.
you have a holy war against floating abstractions.
Yes.
It's fantastic to see, to unravel. I mean, it's just fantastic. So, uh, I cannot recommend enough this book. It's it's
Thank
it's
you.
really good. It's really good. Mental abstractions. Mental models. Let's go there. Um, chapter 2. It's great. It tells you about what to do. I mean, okay, how can we make sure that the mental models we have about the systems are correct? So they're a great representation of reality. Understanding the complexity of the system, how deal with that. I love it. So can we talk about that? I mean, what are the tools that you
Yeah.
suggest for keeping your mental models checked and synchronized with reality?
Yeah, that's always a tricky part, right? So one of the things I introduce in chapter 2 is called the E&E approach,
Mhm.
which is evaluation and then experimentation. It's a way, any consultants listening, you'll be very happy about this,
Mhm.
but it's a way that you can help kind of baby step your transformation towards resilience in your company. So first you start with evaluation, which is very much like need to make sure you have your architecture diagrams, need to make sure you have your data flow diagrams, again, how things talk to each other, how the data flows. Ideally, you even have a sense of the backwards edge, like how errors propagate backward. That's often something I see engineering teams miss a lot, and that can lead to very interesting failure scenarios. And once you have those, I'm a huge fan of decision trees. I actually put in a lot of love into an open source tool called Deciduous that helps you create these decision trees and spoke about it at SREcon earlier this year. So there's a concept from behavioral economics, or really it's behavioral game theory, called belief prompting. It's similar. Most people are probably familiar with how chess works. The idea is very similar to like you mentally model like, well, if I make this move, then the other person will make this move and then this and this. You can do that as a defender versus an attacker. You can actually do that as, like an SRE versus just reality and the machine. Like if we implement this kind of control, like what will happen instead? But really the power with this belief prompting and documenting it in a decision tree is you're documenting your assumptions about the reality of your system. You're documenting how you think events will unfold in a certain scenario. And you don't even have to conduct any real experiments. This can be entirely a collaborative exercise. I have seen, though, when I am brought into companies who are really gung-ho to start doing experimentation and resilient stress testing, a lot of times when we just do the basic decision trees, they discover, oh, wow, there's a lot we've overlooked we didn't realize. So maybe we need to take care of all of that stuff before we try the experiments. So once you kind of have your, what I would call kind of like critical adverse scenarios with your decision trees, you have those architecture diagrams, data flows, then you basically cultivated these hypotheses and you can apply the scientific method. And that's phase 2, which is experimentation. In software, we call them chaos experiments. In literally every other domain, and I mean healthcare, financial services, urban planning, water management systems, aerospace, they call it resilient stress testing. So I wasn't the one who came up with the chaos engineering term, but you can call it whatever you want. I would say executive buy-in tends to be better with resilient stress testing. So in this phase, we do resilient stress testing, which is we simulate adverse scenarios to understand how our system behaves end to end. This is not like a unit test or like load testing. This is very much you are injecting some sort of adverse behavior to see how the whole socio-technical system behaves end to end once it's undergoing this scenario. So as an example, Aaron Reinhardt, who wrote the chapter on case studies in the book, he's the heart and soul of the security chaos engineering community. He actually invented the first security chaos experiment at United Health Group. And what they found is the hypothesis they created when they thought through their assumptions was, okay, we expect the firewall to detect and block an alert on a misconfigured port. Pretty reasonable. That's what they're designed to do. They conducted the experiment, and what they found is that it only did that 60% of the time. So it's like Anchorman 2, 60% of the time, it works every time. That's pretty abysmal when you have expected that to work 100% of the time. What was interesting, though, is they found that the commodity cloud configuration management tool, something all of your listeners will be familiar with, that caught the misconfigured port. And so what we see a lot actually is that a lot of the tools that engineering teams are already using, their observability stack, the system signals they're collecting, all of that is very useful even for cybersecurity scenarios, even when we're talking about attacks. So it can expose both when your controls aren't working and expose when, hey, actually this control that we didn't expect to be helping is helping. So I think that's a great example of an experiment because you want to start with those things where you're pretty certain in your mental model, you're like, yeah, this is always true. Like we know for sure. If you already know, like, we're not sure if this is working or implemented properly, don't do an experiment, like fix it, right? You want to definitely focus on things that you are pretty sure aren't going to break everything, right? But then also the ones where you're very sure about your assumptions. That's the way to start small. So I highly recommend the E&E approach because you basically document all those assumptions. You're basically collecting your mental models of the system, and then you're exposing those mental models to reality again, not just how the machines and tools behave, but also how the humans behave. Because maybe you generate an alert, but that's one of like 10,000 alerts in a day. And so of course your teams don't actually detect it. And that's important to surface too, because if you think that, oh, if we generate an alert, we're going to be able to close out the incident in less than 10 minutes or something like that. Well, you want to validate that assumption, right? So that's what we mean by end to end. It's not just looking at, does it generate an alert? It's, well, what happens after the alert as well.
That's fantastic. I mean, it's that tree. It's like a propositional system. It's like I have these predicates and holdouts, and I have to check all those predicates to see if they are true or false. And
precisely,
it's fantastic. It's just great.
I'm excited about it, so I'm glad you are too.
I'm geek about this, so it's great. I mean, it's like applying logic and epistemology to this. It's just great.
Yeah.
It's fantastic. Yeah. Well, sorry, Herring. Just
no.
And get excited. In chapter 4, it's hard for me to pick a favorite chapter. It's very hard. But chapter 4, I think, is very relatable to software engineer that is not yet into security or resilience,
Mhm.
because as a common software engineer will look at it and will say, "Yeah, I get it." Yeah, well,
Yeah,
I don't have to change much in my day to day,
right.
right? Am I right?
Yeah, it's mostly right. I think one of the key lessons I wanted to really indicate is the cybersecurity industry thrives on these like bolt-on tools and again policies and all of
Mhm.
that. Actually, if we want to achieve again resilience against attacks, a lot of it is more how do we implement these design-based defenses? How do we reduce hazardous methods and
Mhm.
materials, as I call them, by design? Like I analogize C code to like lead. Like it's really useful, but it kind of
Mhm.
poisons us over time. So we can either refactor into a memory safe language. We can use things like sandboxing and isolation. There are a bunch of ways we can treat it. But I think the core message I really wanted to communicate to software engineering teams or platform engineering teams is a lot of the practices you already have adopted and the things that you do for software quality and to uphold things like reliability. Turns out if you just think about them slightly differently, they apply to security as well. So like type safety and type systems, like that's something that a lot of engineers are like, that doesn't have to do with security, right? And it's like, well, actually it does. It might be, again, a kind of a second order move.
Mhm.
But to me, like as a first approximation for what's good code, it's codes that's easy to refactor. We always hear about how attackers are like nimble and ever evolving and all of that. And it's like, well, we should do that too if we're going to be adapting to like as attackers adapt their methods and being able to refactor code more easily through something like a like static typing system can actually help. There's certainly things I mentioned again, like memory safety, that are huge boons. Things like integration testing. I know that there are engineers out there that are like, oh my God, why doesn't my organization implement integration testing? It would help us so much. Well, now you have a reason to. That's not just about quality, it's also about security. Because it turns out a lot of security issues can be caught through integration tests. Because again, it looks at the interaction between things and it exposes
Mhm.
when that isn't behaving as intended. So I tried to really select a lot of these things, again, that software engineers know well. And it's like, hey, if you think about this a little differently, turns out it helps solve some
Mhm.
security problems too.
Mhm. 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 Fantastic. Eric, I will silence myself for a bit.
No, no, no worries.
Make it
I love
count.
it.
Make the most of it.
Yeah. I understand. I understand your passion for philosophy. So I ceded the floor for a while. No problem at
Okay.
all.
Gracias.
Um,
Thank you.
Kelly, one of the, and this relates to what you were just talking about with integration testing, I think, too, is one of the myths that you described in your book about the security, the myth being that the security of each component adds up to resilience. And so, as I understood that, your concern is that an engineering leader shouldn't assume that the full system is secure just because they did some level of like unit testing, component level testing on each individual component and its security. So when you have a system architecture that's loosely coupled, that's like a microservice or component oriented architecture, what is the best way uh, to ensure system level security across those components?
Yeah, that's a great question. I'm a huge fan, certainly, of anything like integration testing. I'm actually not a fan of unit testing for all the reasons we talked about with mental models, is because unit
Mhm.
tests are often just testing the mental model like on itself,
Mhm.
which isn't very helpful.
Mhm.
I think
Mhm.
generally, again, if we want to align with reality, we shouldn't write tests that pretend reality looks like our mental model. So
Mhm.
I'm not. I'm definitely, if you had to choose between unit tests and integration tests, I would vote integration tests basically every time. Again, I certainly think for again a loosely coupled architecture, I think those are actually interesting because I've noticed a lot of times there are different kind of dimensions or levels of abstraction with loose coupling. So you can have like layer 8 loose coupling, right, where you can make changes independently. That's super important, and I actually think probably is the biggest reason why I see organizations adopting microservices is that. But if you want loose coupling in the sense of like things can fail independently, that's often that often is not true in practice. And so things like integration tests absolutely can help with that. I'm a big fan, again, of course, of chaos experiments / resilience stress tests. Just like pump up those like CPU CPU usage, like push things towards their maximum limits. I have actually in chapter 8 a whole just like list of tables of like experiments you could potentially conduct. By the way, you can absolutely conduct them in staging, not production if you want. There's no, I know like a lot of the hardcore chaos people are like, you have to test in prod. Like, no, if you're getting started, just do staging. It's better than nothing. So yeah, I think there are a lot of things that, again, you have these assumptions of like how the microservices interact, but you really want to understand how those failures propagate, how, again, that backwards edge looks, like how errors can propagate backwards, where there's back pressure. So I'm just a big fan of just like play around with the system, like think about like what would make for a really bad day. Like, again, like your transaction processing system, suddenly is getting like DOSed by an attacker. It's like, well, does that affect other services? A key thing also is, are you able to take that service offline and deploy a fix without affecting other microservices? Things like queues and message brokers can really help with that. You can almost create like a temporary air gap when you use those technologies. Again, that's something that cybersecurity people, by the way, I have to teach them what queues and message brokers are. You all already know it. So you could already be doing this without having to learn that. So I think this is kind of like a long answer, but I think it's the combination of like experiment as much as you can. If you are still a little shy about experiments, like do those integration tests. Even things like load testing can still help. Just like see what happens in the system, start in staging if you want, and then very much think about like not just the can we change things independently, but like can this fail independently in those like directions of flows to see like how failure propagates, like not just in the one server, but like how it could cascade out.
I have an assumption that I'd like to hear your feedback on that. Part of the reason, kind of historically, in the dark ages of security, as you described it, that we have this like conflict between maybe a developer mindset and a security mindset, is that security was often, like a lot of system level testing, brought in at the end of a long phase of work, right? And so it becomes seen by the development team as kind of an obstacle to them being done and moving on to the next thing, right? And you see that in a lot of that tension, and I think in a lot of especially more traditional engineering literature. Given though that a lot of this is done at kind of an integration testing level, and so a lot of work perhaps has been already done by a component level team prior to that integration test, what is the best way to kind of bring that security mindset forward into the team? And what do you see, like in a Scrum team, for example? Should there be a security expert in there, or is it more about trying to have a security expert across multiple teams who is kind of educating the members of those teams? How do you like to sort of distribute that role?
I've seen a few different models work. Certainly what's called the security champions model, which is basically like you have the security expert that acts as an advisor. That can work really well. The security team almost becomes just like, again, like a strategic advisor to engineering teams as issues come up. I definitely argue, though, that you want security to look as close to platform engineering as possible, so things become self-serve. That you don't have like this long like review every time ad hoc of like, here's how to implement your password requirements. It's like, no, make it accessible documentation, make it self-serve, integrate things into like CI/CD whenever possible. Huge fan of something like Dependabot. Just like you click a button and you upgrade like a vulnerable library. Like that's great. Like I can't ask for better. I do think if we look at kind of like a core contributing factor behind what you described in the dark ages, it's security doesn't really think about UX ever. And so they don't really understand how developers do their work. That's actually something I teach a lot of security leaders and teams, is how software delivery actually works. That's part of the function of the book too, is like, hey, here are actually all the steps. There are opportunities to integrate things like static analysis into IDEs. Again, really respecting the developer's attention and that they don't want a context switch, and how do we bring more security into that workflow? So I guess that's to say there are opportunities at basically every step of that workflow to integrate security. I am not a huge fan of like DevSecOps. I'm using air quotes for anyone just listening. DevSecOps, where like shift left, when it's just like shifting the obstruction earlier. I don't know how much that actually helps. But I think, again, the reality is part of the reason why you see huge backlogs of like manual security reviews before release is because security teams don't understand the systems they're protecting. It takes them longer to do those code reviews. And I think that's absolutely something that can be self-served. Another thing I've seen is successful CISOs oftentimes are like, hey, if this is like an experimental thing, if you deploy it in a serverless environment, you're good to go. Like, we don't have as many security checks, because when it's like immutable and ephemeral, just the attack surface you have to worry about is much less. You get that true kind of like failure isolation. That means that, like, good luck. I don't think I've ever heard of like serverless ransomware, like maybe in 10 years, but it's just very hard because attackers have to break out of perform like a double escape to break out of a serverless environment. So you can have all the bugs in your code if you want. It's just like, congrats, you got this one instance. It's very hard to gain anything else from attackers' perspective. That leads me to an important point, because I'm not sure how much security experts are actually needed on the teams. So one thing, again, I was trying to teach in the book that a lot of developers and software engineers, especially SRE types, don't realize is attackers are much closer to them than cybersecurity professionals. So if you look at like criminal organizations, what we've learned from them, they're investing in their infrastructure, they're investing in automation, they are creating, management portals, like actual UIs for their customers to engage, to conduct their ransomware operations. They have great kind of customer success. They are kind of like a tech startup in a sense. They have much more financial infrastructure, but they're essentially a tech startup. You have the people who are like writing the malware, writing the code for the UI portal, and then you have the equivalent of SREs. So instead of monitoring the system to like make sure it's up and healthy, in a sense, they're monitoring the system to make sure they're not getting caught, to make sure that whatever they're doing isn't going to trip over thresholds and other signals. So actually, you just doing your job, you can relate a lot. All you have to think about is that alternate perspective of like, okay, this system I'm working on and I've like written code for it. How would I try to take it offline? Like, how could I hold it ransom if I was like really mad at my employer one day? How would I, if I, got access to service A, but I really wanted access to like service C that had customer data, how would I get there? Like if I were just like a rogue developer, you're going to get really close to the attacker mindset that way. And that's what you want, because ultimately attackers have bosses and budgets. They think about ROI. They're going to take the easiest path they can to get to their goal. They're not going to do the crazy, like multiple 0 days chained together and, all of that stuff. So as long as you're thinking about kind of the obvious ways, like if you're a lazy developer, you would be able to like pivot in your own system and attack it. Probably you're going to eliminate a lot of the low-hanging fruit. And so that's something I'm hoping empowers a lot of engineering leaders, is like, hey, maybe we can start just thinking about this as part of our like architecture and design thinking too.
Building custom WebRTC video applications is hard, but your go-live doesn't have to be stressful.
We thought we were ready to launch our video application, but we discovered it's a lot harder than we thought. Live video applications are not like building other web or mobile apps. Our team worked hard out there today, but we just didn't have all the right pieces. I'll tell you what we should have done. We should have brought in the live video experts from WebRTC Ventures.
If you're building a live video application, then trust the experts at WebRTC.Ventures to help you design, build, test, deploy, and manage your custom-built application, or integrate live video into your existing application. Contact us today at WebRTC.Ventures.
So if an engineering team and the sort of existing developers on it, if they think about that low-hanging fruit and eliminating those easiest paths for the attackers, let's say that maybe they could eliminate 80% of sort of the attack surface, or potential adverse situations. How do you, in what situations do you decide to bring in outside help? Would that just be for that sort of last 20%, or specific types of use cases? Where is it better to bring in someone with an external perspective?
I always think bringing them in early for like architecture and design. This is another place where like decision trees shine, is they hopefully have knowledge of like, here's what we've seen in the wild of how attackers have been kind of like navigating systems and attacking them. And so if you're creating something like decision trees, you have your own assumptions, like we just talked about, that you can document. You can get their take on like, okay, what assumptions are missing here? Like, what are the likely paths that attackers will try? And that can flesh out the decision tree and help you inform mitigations ahead of time. Again, ideally by design. I also think sometimes you don't need to care about that 20%. Like once you've narrowed it down to like the attacker has to use exploit 0-day vulnerabilities to achieve their goal, you've done a really good job. Like you've made it really hard for the attacker. You should be honestly proud at that point. And I actually think the more important point in general is like, how do you minimize incident impact? How do you improve, again, like the isolation of impact? How do you make it hard? Like, let's say the attacker can get initial access and they do something fancy. How do you make it hard for them to do anything else though? Because I think it's 95% according to Verizon, their data breach investigations report, which is kind of the gold standard. 95% of attacks are financially motivated. So they're looking at like, how can we like get your data or seize your resources so we can make money? And if you can make it hard for them to make money, that's a plus. They'll likely move on to different targets. So again, you can't always control for like when there's a 0-day vulnerability, especially in third-party software, but you can absolutely think about how do we minimize the impact. And I'm obviously a huge fan of things like WebAssembly and again, serverless or really any sort of immutable infrastructure, because that makes it hard. Like the attacker can't just pop a shell. You disable SSH into a container. The attacker's not like, well, how am I going to persist and like really leverage this resource to its greatest effect? So again, there are a lot of like design-based things maybe we want for reliability, and now we can add this security argument into it too.
This reminds me of a phrase that you use in the book, the distinction between a system that is fail-safe and safe to fail. So maybe talk a little bit about the distinction between those terms, please.
Yeah, so fail-safe is basically like, we have prevented failure from happening. Like failure cannot happen, which obviously is impossible. It's just like, it's in any area of life, we can never prevent failure. It's just the cosmos is chaotic, right? But safe to fail means that even if failure happens, it's not a big deal. It's the same reason why people have like backups of their keys in case you lose them. You can still enter your house. Like there are tons of examples in real life where we've designed things to be safe to fail because fail safe isn't reliable. We can think that we're improving reliability because we've like stopped all the possible paths to failure. There will always be something that surprises us. If we want to build anything really that solves a problem in a valuable or meaningful way, it means we're going to have complexity. It means there's going to be complexity in our systems. And that means there are going to be these baffling interactions, as I call them, and other resilience people call them, that surprise us and astonish us. I'm sure every listener has had some sort of incident where they're like, wait, how, what? Like, what exactly happened? I had no idea this was even possible. And I hear that a lot as well. And that's exactly the thing. If you have fail safe, you're not going to anticipate those baffling interactions. And it means that failure is going to be like more like a mire, and it's going to hurt your like time to recovery metrics. It's going to be very costly to clean up. But if you make it safe to fail, you know that like failure will happen. We need to be able to recover quickly. We need to be able to investigate and learn from it so we can continue adapting. It's just a much like faster cycle of change rather than fail safe, which often restricts change because change could introduce new avenues to failure. And it's like, well, I think in the book, one of my favorite things that I wrote was like, it's akin to if you're going rollerblading, you could wrap yourself up in like a bubble suit, you just like tons of bubble wrap around you and you move very slowly. And then like a dog barks and you get scared and you fall over and then you can't go anywhere. Instead, you can just wear padding, like kind of basic safety things, and you can still reach to your destination, dodge the dog and like deal with the wind. So we don't want to be so fail safe that we just choke innovation, right? That's not healthy either.
So that gets, I think, to a really important concept for the engineering manager is how to communicate that message. I mean, I really appreciate how you write about perfect security doesn't, really exist. And you talked in the beginning of our conversation about using terms like system resilience instead of chaos engineering, right? How should an engineering leader kind of communicate that balance to executive management and that sort of constant risk that something's going to happen? We're just going to deal with it more gracefully than we used to, and that should be okay, right?
Yeah, I think. There are a few different tactics. One thing I think is always highlighting the business case, which is that resilience is not just actually adapting. It's about adapting to evolving conditions. Those can be bad, like attacks. Those can also be good, like opportunities. There are a lot of companies that missed out on like the move to cloud and some other innovation because they were, stamping or choking out change because of cybersecurity. that doesn't make the business resilient, because that means it hasn't been resilient to like market shifts. So I think that's one really important framing, is to show like, hey, we're aligned to the business. We want to help you succeed. We want to help you better adapt as market conditions evolve, to create differentiators. Resilience is one way to get there, because it's not saying, no, we can't have change. It's saying, okay, let's change, but make sure that it's reliable. Let's make sure we can sustain this success, and it's not going to be like a short-term win for a longer-term danger. So I think that's one thing that's really powerful, is just showing how aligned it is with the ideas of innovation and developer velocity. I think it can be tricky when you're telling an executive like, hey, things will fail. But I think the caveat is, wouldn't it be better if we recover within seconds rather than recovering within hours? And that's normally the trade-off. It's not a trade-off between like no failure and then failure happens. And so, right, it's actually, failure is still going to happen in the other case. It's just going to be way more onerous to clean up. It's going to be more expensive for the business. It's going to be harder to change things afterwards. And you get out of that really pernicious cycle of like big, messy failure, suddenly a huge investment in cybersecurity or whatever it is. And then the memory of the incident fades. And it's like, well, okay, do we actually care about this? And things stagnate. And then you have the really big incident again. You get out of that almost like fight or flight mode. It's like, okay, we can handle this. Like, we're capable. And I can definitely tell you, customers love when their vendors can recover quickly. They like, if we think about outage in like e-commerce service, for instance, or financial service, whatever it is, consumer facing, if there's a 1 second blip, they're not going to care. If there's a 2-hour outage, that's not so great. Even the time of day matters, right? Like if you're a US focused company and it happens at, 3 a.m. Pacific, it's not that big of a deal, right? So I think that's a really important message, is just that this isn't a trade-off between no failure and failure's happening. Failure is going to happen either way, but let's make sure that there's no material impact, that we don't have to like disclose it to investors, that it doesn't become, a big like SEC concern or whatever else. And so that's a message I've seen resonate as well.
I'm feeling a lot of anxiety because time is running out, and I have so many questions. Can you talk about the effort investment portfolio? I think it's a brilliant idea. It's brilliant. Please unpack it. Yeah,
so I have a finance background, so I often think in like financial terms. So the effort investment portfolio is basically the idea that our effort is finite, which a lot of people forget. We can't invest in everything. We can't, I'm big into like a bunch of hobbies, drawing, watercoloring, like gardening, like all this. In any given day, though, there's only so much effort I can actually allocate. And that's very much true for teams. So one thing that I really like is when you investing your effort, the idea is you're supposed to get return from it. So you always want to make sure whenever you're planning out, planning your strategy for the year, for the quarter, it's like, okay, what do we expect in terms of return from this effort? And that's where, again, those design-based solutions for cybersecurity start to shine. Because you could spend, 12 hours in security awareness training multiplied by all of your developers. Maybe, again, you adopt immutable infrastructure, or you refactor to a memory-safe language. Refactoring involves an enormous amount of effort, but you also have to think about where that effort is happening. Maybe it's easier for your, product engineering teams, but maybe your SRE team is getting absolutely crushed from an incident perspective because, you have C and that has its own host of problems. Maybe you're getting a ton of compliance fines because of all the incidents you're having. Like whatever it is, it's really thinking about effort across, again, the whole socio-technical system, and where we can invest a little more effort to save effort down the line. It's part of the reason also in the book I present it as kind of a menagerie of opportunities, because certainly don't try to invest effort in everything I mentioned, because that's going to be, I think, a multi-year effort. It's very much thinking, okay, based on our context, based on our developer skills, based on, where we, our organizational priorities. Like, again, maybe you were already thinking about moving or adopting serverless for some of your R&D. Maybe you're already thinking about that immutable infrastructure. Now that means that it could be worth the effort investment. For a big multinational bank, maybe it's not, because that's going to involve a lot of effort, especially on the like cultural and political side, right? And maybe it'll be easier for you all to, there are a lot of like potential design-based changes, but maybe it makes more sense to, start to use the strangler fig pattern to start like breaking things out just into microservices, even if they're not deployed somewhere fancy. There are a bunch of different tactics basically that you can adopt that depend on your context. And that's really the idea with the effort investment portfolio, is like you have a finite amount of effort capital, as I call it. You should be very purposeful about where you're investing that effort and making sure that you're always going to get a return from it, which I also hope dissuades some of that resume-driven development that we all see and can cause a lot of headaches down the line too.
I think it's a great idea. You gave a lot of examples, but one that is very easy to grasp is when um, um, you decide in investing in things like logging and observability to reduce the
Yes.
cognitive load during incident response. Uh, Now, again, I want to make the comment. That is a very philosophical observation. Is because, I mean, the fact that you are taking into account that humans, we have, uh, um, I mean, that we cannot perceive everything at once, at the same time.
Right.
You're like probably you've heard this, the crow epistemology or unit
Mhm.
economy, unit consciousness. I mean, we have we came up with them. I mean, we already come with mechanisms to deal with that by um, creating better and better concepts. But in your book, you give a lot of tools so we as humans can deal with the cognitive overload because
Yes.
this is very complex. So it's tons of information. And you made a comment in that same chapter, I think chapter 6, uh, and you mentioned the local rationality is again a
Yes.
bit about the same thing, is that we make decisions based on the context that we have now and the things
Right.
that we can fit in our focal awareness. uh,
Right.
so and that taking that into account is very important um, um, uh, to um, to understand when things went right or wrong
Right.
in incident responses. um,
Absolutely.
yeah, I love that. I mean, that observation is brilliant. Yeah, it's great. It's great. Thank you
Yeah,
very much.
thank you. No, I think it's a really important point that when things go wrong, if you're blaming the human, that is the ultimate human error, ironically. If you aren't looking at like where it's an opportunity to redesign either system design or like the design of a practice or process, then you're missing the point and you're probably going to have the same incident again. Humans generally try to do the right thing, and humans, like you said, with local rationality, the idea there is that there's not this globally rational decision. It's that people make the most rational decision they can given their constraints and their context and the information they have because they're not omnipotent or omniscient, right?
Right.
And so
That's
it's
awesome.
really important to, yeah, it's really important to think about like, okay, let's respect that. Um, Healthcare has been through the same journey, by the way, where, you know, if you poll surgeons like, well, would you have made this decision? They're like, absolutely not. Present it differently. And you're like, okay, here's the local context that same surgeon had that resulted in, let's say, a patient death. The surgeons are like, well, I would do this thing. And that's what the other surgeon did too, right? It's very easy for us to be like, well, I would have known better. It's like, well, would you have if you were in the exact same scenario? And most of the time, the answer is not. So again, it's an opportunity for us to think about how do we redesign things. And that's where effort again comes in is we put in more effort to redesign something, to think about those design based solutions, to invest in logging, like you said, during the development phase, or things like distributed tracing so we can understand how data flows through the system, which is very relevant in cybersecurity, for instance, with like data exfiltration to understand how an attacker moved through your system. So we invest in that. It means that we're actually saving effort down the line and having to respond to an incident, and saving a ton of just like emotional turmoil too, which I know a lot of people in tech try to pretend like we don't have emotions, but we do,
We
and
do.
they're signals. Just like, you know, a very unhappy computer wails in its own way, we also can get overloaded and we have signals that we emit. So I think it's respecting all of that, and not dismissing it, and using as much as we can as a teacher, rather than as an opportunity to like point fingers.
Fantastic. Time is of the essence, but I chapter 8, the last chapter. I would love to keep talking here. I'm sorry, but chapter 8, as my last uh, comment or question, talks about security chaos experimentation.
Yes.
It's a fantastic chapter because now with all you you build up on. I mean, you build expectation. Okay, I get this, I get this. This is implemented, and then we get to chapter 8. So you finally see it in action. Um,
Yes.
would it be possible if you can, I don't know, provide like a step by step example of how to do it?
Yeah. So again, I very much recommend starting with something like decision trees, like come up with your hypotheses. I describe them as like, this will always be true assumptions, or like TWAP assumptions for short. It's a horrible acronym, but it is memorable. So start with those assumptions and choose one that you think you can conduct an experiment. Like you have a team that you think will be game to like try this. And I definitely recommend starting small, right? And then once you have that, a lot of this is actually very similar to a software release, where you want to make sure that everything's documented. You document your assumptions, you document your equivalent of a release plan, you make sure everyone's in the loop, you foster consensus, all that good stuff. Then you, in essence, deploy the experiment. You want to make sure that you have all your collection in place to collect whatever sort of signals that you need to. Then once the experiment runs, you write up your findings, you disseminate it, ideally to learn. Ideally, you hold some sort of equivalent to a postmortem where you're like sharing this information with people, again, in a very digestible way. And then from there, ideally, you make the experiment continuous. There are always like some kinks to iron out. But if you make it continuous, it means that as changes are introduced, and we have a case study in the book, I think it's Verizon, where one of the ways that they use it is to actually show like basically, here's how your security mental model changes when you introduce like whatever kind of like new change or feature or whatnot. So a continuous experiment can make sure that you're keeping your mental models fresh as changes are introduced in the system. That is a gross oversimplification of chapter 8, but that's roughly it. But I would definitely, like Aaron, for instance, and other people who've conducted this in practice, and certainly what I've seen too, is that the cultural part or the socio part is actually harder than the technical part. Experiments, like you can ask ChatGPT for experiment code. It's actually not that bad. Experiments are not like this huge feat of engineering. It's much more getting people comfortable, getting people ready, making sure it's sustainable, making sure that all the insights are disseminated so they contribute to learning. And that's something kind of in a meta level. Also, you're always looking to iteratively improve that whole process too. You're trying to make it resilient in its own sense and making sure that it adapts as your organizational conditions do too.
Love it.
If there's anything we've learned in all the across all the interviews that we've done in this podcast, it's perhaps the one, if I had to make it one theme, it's not always the technology, it's the culture and the human part that's the hardest part. And certainly true here again with security. But I love the comment that you said earlier, Kelly, about if you're blaming an incident on the human, that's the biggest human error you can probably make. So it is a double-edged sword for sure. Well, Kelly, really appreciate the time speaking with us today. The book is Security Chaos Engineering from O'Reilly. How can our listeners get in touch with you and learn more?
Yeah, I'm on, I feel like every week there's like a new social media platform. I'm on most of them. I also can be reached at info@kellyshortridge.com for any, people want to engage me to help with some of the stuff. Casual stuff, if you want to get philosophical, there's chat@shortridge.io. And I'm always on the lookout. Like if you want to see me at a conference or want a book signing at a conference or something, tell me, because I love to meet people who also want to get like nerdy and philosophical too.
Good.
Excellent.
Yeah. Philosophy nerds unite.
Exactly.
There are dozens of us. Yeah.
I can bring this guy with me.
Yeah, exactly. Yeah.
Good.
Excellent. All right. Well, thank you so much, Kelly. Thank you for joining us on the Scaling Tech Podcast.
Thank you for having me.
Thanks for joining us on the Scaling Tech Podcast, where we help you manage your growing engineering team. Brought to you by agilityfeet.com, experts in staffing engineering teams in Latin America for clients globally. For more information on today's episode and to submit your ideas for future guests, please visit scalingtechpod.com.